Hi, I'm Dr. Peter Peterson, and today I'm going to show you how to get logged into UMDCYL, edit a program, see how it works, submit the program for scoring, and a few other fun things. So the first thing is to take your web browser and go to the home page, which is umdcyl.d.umn.edu. And today we're going to go to Apple Hunt. So you're going to go to the URL visible up here at the top, which is umdcyl.d.umn.edu/play/apple. Okay? And when I hit enter, we're going to see the home page for the Apple Hunt page. And you'll see two tabs here, the intro tab and the bot tab. So the intro tab is all documentation. So it tells you kind of about the game itself at the top part of the page. And there's a default program that we'll see in a minute. So this describes what the default program does. And the default program uses some if statements. So we have some description of how if statements work here. And the first kind of task that you're going to try out when you play with the program is how to get apples, how to collect the apples. And then the second part is how to avoid pits. So there are some traps that start showing up and you want to try to avoid those. And we'll talk about that in a second. Then below the game-specific information, there's a whole reference document for the language. So if you have questions about the language, how it works, what you can do, that's going to be described here below the little Python reference. But let's go back up to the top of the page. And you will get a token that allows you to log in. So if I click login, there's a little window that pops up here, and I'm going to enter my token. Okay, and then I hit enter. And now you'll see that I've got my intro tab, my bot tab, and a school scoreboard tab. If I click on this, nobody has submitted for this demo garage yet, so there's no scores here. The interesting part is the bot tab. Okay, and often when you see it, you see the page, it'll look like this. On the left-hand side, you'll have this display window, and on the right-hand side, you'll have the program. I've zoomed in a little bit so that it's easier to read the text. So here we've got the play window on the top and the text window on the bottom. Okay, and as you can see, the program comes with the default program here. What this program does is it picks a random direction and it moves in it. So it's beyond the scope of this video, but if you read the intro tab up here at the top, it'll explain how this code works in general. But a equals rand %4. The percent operator is actually something called the modulo operator, and that's essentially the remainder of division. So rand is a random number, and then we divide it by 4, and the result the remainder is stored into A. And so the way that works is if you divide by 4 and take the remainder, you can really only have 4 possible remainders, 0, 1, 2, and 3. And that's an easy way to make a random number fall into one of these 4 categories. So then we say if A is 0, then we're going to move east. Okay, in your program, you always want to set a move, which is going to be something like east or west or maybe south or north. In some games you can fire or take other actions. Okay, so here we set move to east. If A is 0, if A is 1, move is west. If A is 2, move is north. And if A is 3, move is south. So that's all this robot does, is it rolls a random number here, and then it picks a random direction based on the random number. So now if we scroll back up here to the game area, and I click, down here rather, at the bottom of the programming window, if I click play, it'll load, and then we get to see the robot moving around randomly. All right, now obviously it's not a very efficient way to look for apples by running around randomly, but that's what the base program does. Now I want to show you a couple features here. We have, I'll zoom out so you can see both next to each other. Okay, so we have down here some controls. Okay, so I can pause the playback. I can hit play again and it'll keep going. I can scoot back individual steps. You can see in the timeline down here, I'm actually going backwards one step at a time. Okay, going forwards one step at a time. I can click stop and start over at the beginning. I can play and I can speed up the playback by clicking this button multiple times. So you can see now it's moving very fast. All right, if I hit stop and play again, it's back to the normal speed. Now there's also something called the debug table. And what the debug table does is it shows the state of the game per each frame. Okay, so remember A is that random value from 0, 1, 2, or 3 that we pick. And then move is the value that we're setting it to. Okay, we'll talk about pit to east, pit to north, pit to south, and pit to west, and exter and wider in a moment. But for now, what you can see is that as the robot moves, we can see in the debug table what the whole state of the game is. Okay, so now I'm going to click stop. Now, if you look here in the documentation, now any line that starts with a pound sign, the hash mark, is what's called a comment. And that means that it's not really part of the program, but we can use it to document our code or provide other information. So the robot in this game has two sensors, exter, which says the direction, the horizontal direction to the closest apple. So it will either be set to 0 if you're horizontally, above or below an apple, east if the nearest apple to you is to the east, or west if the nearest apple is to the west. And wider will tell you the same for the north and south direction. Okay? So we can use our program. I'm going to get rid of this random program because it's not that good. And we can use this wider and exter to direct the direction of our robot. So I will say if exter is east, okay, meaning if exter says east, then we want to move east. So we move equals east means we set the value of move to east. And then if exter is west, then we'll set move equal to west. Okay. If wider is north, then we'll set move equal to north. And if wider is south, then we'll set move equal to south. Okay, so now let's hit play and see how this robot does. This robot goes straight for the apples because it knows how to find them. Okay? So now these are traps, these X's, and if we crash into one of those X's, the game will end. Okay, I think we crashed into this X. Okay? Now if I hit stop and I hit play again, you can see exter and wider is set to west or south, and the move is going to be set to one of those values. Excuse me, I have a cough today. All right. So once again, now here our problem is we've walked into this trap, and so that ends our game. Okay. So what we can do is we can use, at every turn of the game, this program gets run from top to bottom. Okay, so exter is east, move equals east, exter is west, move equals west, wider equals north, move equals north, wider equals south, move equals south. Okay. Now, what we could do is we can also check to see if pit is to east, pit to west, pit to south, or pit to north. Okay, so we could do something like if pit to east so if pit to east is going to be true if there's a pit directly to the east of the robot. Okay, immediately to the robot's east. Okay, so if there's a pit to the east, then maybe we can move south. Okay, so we're going to try to go around it. We could also say if pit to east or pit to west, move equals south, and if pit to north or pit to south, move equals west. Okay, so we're going to try to use these sensors that can detect the pit to get us to move out of the way. All right, let's see how that works. First, we have to collect all the apples, which is easy after we do our initial program. And you see there's a bug in my program because what happens is if I pause it here, you see pit to west, there's a pit to my west, okay, which is true, there's a pit to the west. And so I'm going to set my value to south. So I go one step further. Now pit to west is 0, and wider equals north, so move is set to north. And so now I'm going to move forward again, but now there's a pit to my west, and there's a pit to my move is south, and so I'm going to move out of the way to try to avoid the pit, and we're going to go back and forth. Okay? So my method to try to avoid the traps isn't very good, and we'll talk about potentially better ways to do that in the future. But for now, I'm reasonably happy with this bot. So how do I get the bot scored? Okay, so what we do to score the bot so that it shows up in the school scoreboard is we have to submit the bot. If you go down here and you click submit, this takes a few seconds because it runs the bot many times. Okay, so in this game it's pretty short, but with other games it can take a little while. So here it's saying your average score is 9.3. So I click OK, and now if I go up here to the school scoreboard, we'll see example bot, average score is 9.3. So now if I improve my bot and I resubmit it, then my score will increase. And if there were other people working on bot programs in this garage, their bots would also be showing up here as they submitted them. So then we could see whose bot performs the best. And then if you're participating in the competition, the UMDCYL competition, what will happen is we'll set a deadline for you to write your best bot for the particular challenge. Okay, it won't be Apple Hunt. Apple Hunt is just our teaching tool, but one of the other programming games. And so when it comes to the deadline, what will happen is the very best bot from your school's scoreboard will be played against all the other bots to see which one gets the highest score. Okay, and so whichever program gets the highest score will be the winner for that particular challenge. Okay, and at the end we'll add up everybody's points and decide the championship school based on that. All right. That's it for this little demo. This shows you how to log in, how to program your bot, how to see it in action. You hit play to see it in action. You can scroll down here to see the values in the debug table that are affecting how your program works. We talked about how you can submit your bot for scoring by pressing the submit button. And we talked about how on the intro tab there's documentation talking about the game and also about Little Python. So if you have any questions, please contact me or send a message to the mailing list, and there will be information for how to do that in the description to this video. So until next time, have fun. Thanks.